30 half. How about that? Half of semester is gone, so we're in the second half. And we started to deal with the statistics part of the course. Statistics with a special textbook in statistics that I shared with everyone, and you technically don't need it, but just the part that we're gonna look at together. So last time we did something from section 2.4 or so. So let me take a look at section 2.4, page 59. So to get 59, I need to take 59 and add about 15, so it'll be like 75 or so. So that way I'll jump right into the page I need. So that's the, I guess, fast way to use online textbooks. So you don't get exactly to page 59, but somewhere in the area you need a little bit faster. So we worked with samples, and that's a group of that data. And we tried to describe sample and to see what else we can do about the sample. So I believe last time we took some numbers and tried to put them in classes and everything. So today I'd like to continue these interesting ideas and just look at smaller sample in exercise number 1 in the section 2.4 that wants us to find so-called average or sample mean statistics. They really like to produce their own terminology. So they call average as a mean, simple mean. Say, Alex, why don't you just call it as average? Yeah, you can call it any way you like, as long as you know that what you want to do is add 6 numbers we have here, and then to divide it by 6 to average those elements. So you add those numbers and divide by 6, and well, you want to use the calculator for that, right? You want to definitely utilize the calculator. And what I'll do is I'll use technology. So I'm going to copy this data. So just right click and PC. I right click, I know in Macintosh, probably some other procedure, but I want to highlight these and then paste them in the special calculator. So what I do is I will show you absolutely free and very useful standard deviation calculator. Standard deviation. So it should appear here. Standard deviation calculator. Say what? Standard deviation? Yeah, that's something we're going to get used to. So when I select the first choice, what I do is I get rid of whatever they offer here as example, and right click my mouse and paste data into that calculator. And I need to separate my numbers with commas. So I'm gonna put commas after each number in this sample. And sample, that's what we are dealing with, right? Sample, it's a group of elements. I say there is a population. Well, we're never going to use population. We just use sample, and then I click calculate, and this calculator will actually produce for me what I need for this group of data, that average, which is mean, that ends up being 157 and something, right? 157.83 dot 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 bunch of trees. It also gives us, since it's standard deviation calculator, it also gives us S, standard deviation. Well, not surprisingly, it's called as letter S, and this is about 215 and something 0.719. So let's figure out what this is all about. I know I just used calculator, so I did not really look at the formula for that special values, but let me make sense out of what we produced, and then we'll see what this is really happening. So sample mean, X with little bar, is about 157, 158, one can say approximately, right? About 158. For convenience, we already know we just take better looking numbers so people will not panic when you introduce them with those numbers. And then turns out the standard deviation, if I apply it to the left and to the right of my sample, 215 approximately, will give us a ballpark for the sample elements, which means that if I add 158 and 215, that'd be approximately 5 and 3, and then 7, right? It's 373 on one side. And then on the other side, when I subtract, I'm going to get something negative. So if I subtract, it looks like I got negative 57. So this is something that estimates where my sample elements supposed to be. Like number 0, someplace here, zeros. I have 3 of them, right? Looks like 3 zeros. And then 176 appears once. And then 548, that seems to be kind of far away, but that's the largest. So it tells me that my sample is spread quite a bit around the center where my average, where my sample mean is. So those characteristics of the sample, well, usually designed for big samples, because if we just have a 6-element sample, we probably don't need to estimate anything because they're all in front of us. But if you get 600 element samples, a big sample, then definitely it's helpful to see what is really going on with those sample elements. So that's why they have those special characteristics for the sample, such as a mean and a standard deviation. It's just like for the temperature on the outside. You might go out and feel it's like 50 degrees, but if it's very moist, it may feel like 35, right? And if it's dry, it may feel maybe like 60. So not just temperature, but moisture or some other characteristics of wind or whatever. So analogously for the samples, we like not to just have average, because there may be a sample with nice elements, so everything is pretty much the same, or maybe the sample with elements far away one from the other, the same as many elements, but the spread is huge. And of course, it's no good. So the farther away, farther apart the elements of sample are, the less intuition we have and what is really going on, right? So we always try to have the standard deviation smaller But of course, there's nothing we can do, just take sample and record its elements. But that's a characteristic of sample that we don't want to disregard, standard deviation. And that's what they're talking about. Now, since it's a measuring a level of spread or showing how far away the sample elements are, it's actually in the next section in 2.5. It's here, variation. Then the formula they have here for the standard deviation is definitely something that we, well, I guess, want to skip, because if you start to extract the square roots from various fractions and this Greek letter sigma stands for sum, so you have to subtract mean from each element and add those differences. It's just a lot of work, and they actually do show all work that you can go through among the exercises in this textbook. See, they show how you could use this formula, people say, from scratch, but it's only for a sample of 3 elements. But if you had 23, then you would have to do it 23 times, and that's really a lot of work just for one exercise. But for us, all we want is to use a calculator, and the calculator will give you the answer right away. It doesn't care if you have only 3 elements in your sample, or 23, or 233, or whatever. You just put this in the calculator, copy and paste. Does not take too long, and the calculator will give you the answer. It doesn't care what sample size is, because otherwise, if you have 200 elements sample, well, it'll probably take you about an entire weekend to waste plugging this in, finding differences and so forth, and differences actually have to be squared. So lots of work just to get the exact same result. So nowadays, when we have technology, it's just pointless to do by hand. But the old days, I remember about 15 years ago, I was doing it by hand 20 years ago. So I had a good calculator. And in class, I did these exercises on the board with calculating standard deviation. It would take about an entire 50-minute period to do a couple of problems. But now look at this. I can just copy and paste. So nowadays, things change tremendously. You have technology. You don't even need to be in the classroom, right? So you just open the textbook, you copy. So I'm going to find, again, mean and standard deviation for exercise number 2. So we'll just copy it, paste. And please notice, I don't really care how many sample elements we have here. So I'm going to go to the calculator. So where's the calculator? Here. So I'll go back to clear mess I produced and paste my new sample. Look at the advantage. Paste, and the only thing I need is put a bunch of commas. But it is not that bad, because if I had to retype these decimals, and that would definitely take me much longer, right? But here I just put commas. Well, that's how a calculator works. Otherwise, it'll treat all of these as just one big number, and that's going to be not correct. But when the calculator encounters commas, well, it knows we have another piece of data. So again, it's already sample, and then I click calculate, and I guess for standard deviation. So it takes same as long, pretty much. Yes, just commas, what I need to care about, but look at that. For exercise 2, which is in the section in this textbook 2.4, all I need is to copy mean, the average, So the standard deviation gives me average, which is 80.75. And then standard deviation spread of elements of my sample equal to 468, right? 4.68. So doesn't take too long at all to calculate. I say, Alex, they also say there are 12 elements in this sample. Remember, sample size, how many elements we have here? We have 12. Well, this data, we don't need sum or variance. We don't care from this calculator. We just need mean and standard deviation. So I found those for another question in this textbook. And please notice there's a whole bunch of questions they ask the exact same thing. And if you know how to do one, you know how to do all of them. That's statistics. It's same thing repeats again and again. So it's worth to try to redo one exercise here, and that's good enough. So what is that we produced? Again, let's refresh our memories of what we're doing. We're looking for the center of the sample, or so-called sample mean, X bar, which is equal to what? About 81, roughly speaking. I just want to make sense of what we found. So about 81, and then to the left and to the right, I'm going to step by standard deviation to get a ballpark. So to get to the right, I need to get about what? Approximately 5, right? Close to 5. So if I add 5, move to the right by 5. And if I subtract 5, move to the left by 5. So I'm going to have 86 on one end and 76, right, on the other end. So all my data here, all numbers in this particular sample, should lie in between of 76 and 86. Well, if you look at the actual sample elements, you'll see this is not the case, because the smallest is 70.9, right? So it looks like so 70.9 is somewhere here. And next to it, we'll have 74. It's also a little bit out of range, but it's close to 76 already. And everything else now going to be within the range. So what about the other side? Well, on the other side, looks like my largest number I have is 86.2. So please notice on the other side, 86.2 is pretty much the border. So people say that about 70% of numbers of elements in our sample is within these boundaries. 70%, not all of them, just 70%. And that's good to realize that it's not everything, but it is pretty good description. So please notice that standard deviation here is only 5 compared to a previous example where it was 200. So this sample we have here does not have such a huge spread compared to the previous. So when you're dealing with sample like that, it's people say better. Let's say you're waiting for the bus, and they say, well, you may wait for the bus plus minus 5 minutes. Standard deviation, maybe 5 minutes, maybe faster, maybe a little slower. Well, it's better than if somebody says, you know what, it's going to take you 215 minutes, which is a number of hours, right? So it's like what? 4 hours, something, right? So close to 4 hours. So it is definitely a lot. You need to waste the whole day, pretty much go to the bus stop 4 hours early and then wait, and possibly it may come 4 hours later. So it is within 4 hours in one direction, 4 in the other, like 8 hours range. That's, well, whole day you need to wait for the bus, pretty much. If you come exactly on time, it may be the bus is gone already like 2 hours ago, so it'd be disappointing. So you definitely don't want this to happen. So you want to have situations when your standard deviation is much smaller, so you better can estimate what it is going on. But of course, not everything is within those ranges, about 70%. So one can say, Alex, I want to know for sure where everything is. Well, they say if you look at the other standard deviation, it'd be 95% of your sample if you look at the range of two standard deviations. So now you can see that probably the case here, right? It's about 95% of your sample elements in this example, all sample elements will be within neighborhood of two standard deviations, to the left and to the right. And this is usually the case, even though sometimes we have outliers, cases like in exercise 1 was pretty huge. So if you look at standard deviation, I'm not sure if that largest 548 will be within two standard deviations, probably even not. But it happens very rare. That's for real bad samples. So standard deviation is people say pretty good description that gives you a ballpark. But of course, if you're concerned with better estimates, then you definitely want to do a little bit more research. And they will describe a little bit more research. And there are other parts of this exercise that talk about other characteristics of sample, such as a mode, for example. So if you look at the first example, you see a very popular element in the sample, which is number 0. There are 3 of them. So mode for sample in exercise 1 is 0, the most popular element in the sample is named as mode, turns out. So we have another definition. What is this for? Well, it has nothing to do with mean and standard deviation, the popularity. Usually it's used for data that is not given with numbers, like say brand of the car. What's the popular brand of the car? And they ask, is that Renault, some French car, or Ford, or Honda? And you can just step out in the parking lot and see there is no Renaults. Maybe you find one somewhere, but rare. And 50 Fords, and probably like 60 Toyotas or Hondas. So I would say most popular will be the Toyota. And then it's called mode. And you say, what about the others? Well, the others are not mode. So we don't care for them. It's not mode. Like if I try to find a mode in exercise number 2, I can see that all numbers here are different. There are some decimals, but I don't have the same numbers. Well, since I don't have it, I say no. There is no mode. Makes no sense to talk about repeating numbers, the most popular, because each of them appears only once, and so no popular elements here. Okay, so sometimes you don't have a mode. Sometimes you do, sometimes you do not. Well, don't get disappointed. That's okay. It's just the random numbers given to you. So, anyways, mode and mean. When you say, Alex, there is also so-called median. Well, I don't think I want to do median today because it's going to be too much information. In fact, the story of median follows with a long extra chunk of story that shows where we can use the process. So it'd be lots of information. So we'll do it next time, of course, the median story. So I'm gonna postpone it for now, but I want to show you that we have here end stuff from 2.4 and from 2.5. So actually I gave you lots of information because finding the averages and finding standard deviations is really a big deal at section 2.5. And you can see that 2.4 and 2.5 go very nicely together. I'm going to the end of section 2.5 to show you that exercises in both sections are identical. So look at 2.5. You recognize the same exact samples and in 1 and in 2, but now they ask you not to look for the mean, but to find the standard deviation. I say there's also variance and the range. Well, we're going to care only about standard deviation. So technically, we're done section 2.5 by showing you how to use a calculator. And I think it's really very, very helpful. So otherwise, we would be stuck with this arithmetic for a while. So what I want to do in the meantime, I noticed that it's probably a good idea to give a little quiz every once in a while, right? So just for your own practice. No worries, I'm not going to ask you to find standard deviation. I'll just ask you to find the mode, most popular element. So what I'm going to do is I'll find mode once again. Just take a sample and try to find a mode for it. And then I will ask you to also find the mode. So what I'm going to do is I'm going to just take next exercise 3 that talks about serial. Please notice we don't even care what information we have. They ask to find the mode, so I can see what's the most popular element in the sample is going to be. And it looks like I just need to see what's repeating. 0, 3 does not repeat. Okay. 24 hundredths does not repeat. 0.3 does not repeat. But when I move to 43 hundredths, I can see that it appears again, right? 2 times. Interesting. So is that my mode? Well, let's see if there is going to be an element in this sample that appears and repeats more than 2 times, because otherwise it's going to be another mode. So 0.7, I see only once. 0.47, oh, look at that. 0.47 actually is another mode, right? Please notice that 47 appears twice. Let me say, Alex, wait a second, but 0.43 appears twice. Yes, so they're both candidates for my mode. Let me see. I just looked at the next one, 0.13, and I saw it also appears twice. How about that? And again, it appears 2 times. So these 3 elements, and they are 0.13, right? And also 0.43 and 0.47. They all appear same as many times. So which one is a mode? They all 3 are. Nothing else appears twice. Just these 3 elements, right, appear 2 times. Well, so I have 3 modes in the sample, trimodal sample. Just like that. So whatever this means, you just done your research, you will give it to whoever ordered that research, so they will need to decide what to do with it, right? So I think mode is pretty intuitive type of exercise, and I'm sure you can reproduce mode yourself. So for exercise number 5, that's what we're going to have on a little quiz. Just mode. I don't ask you to find anything else, but find the mode or modes if you see more than one number that repeats and becomes the most popular. So if there is 2 modes or 3 modes or 4 modes or no mode. So question is, find the mode and please put the answer in a Zoom chat, right? In the chat, you can just share the answer, but please send it only to me. Don't share it with the whole class, right? Just don't hurry. Just before you place the answer in the chat, just make sure you send it to only my name. And if you prefer, you can just email it to me, right? If someone is going to watch this recording later after we're done with the lecture, I will, as usual, email you a recording, so you can email me what the mode is. It's fine. So you can take your time. And thank you. Somebody already answered very correctly to me. So if you're done, feel free to log out and have a great rest of the Monday. Enjoy. We will continue with chapter 2 next time on Wednesday. So if you feel like it, you can log out. Have a great day. Bye-bye. Yeah, it doesn't happen too often, but I hope now weather will be better. So anyways, so we have a question, please. If you don't have any questions, I'm gonna stop recording and let you.
Did you receive my
Yes,
my
yes.
answer, Professor?
Thank you. Thank you. I received the answer. So mode is all we need, and